The empty struct in Go may confuse many people, and perhaps you don't even know what its purpose is. That's why in this video we are going to take a quick look at the empty struct in Go. So let's just get started. Okay, let's just first clarify the question, what even is an empty struct? Well, simply put, it is just an empty struct with no fields at all, and it can be defined as an anonymous empty struct, but also as a named empty struct. Let's just take a look at what this actually means here. So I think you are used to the way of declaring variables, not initializing them, just declaring them. Why, we could say just var some int and then use the type right here. We could do the same thing with the string here as well. And then we can also declare an anonymous struct right here by just using var and then some struct. And then we just use this type right here. And right here we've just declared the anonymous empty struct. Obviously we can just put in some fields here, like for instance some int again as a struct field for this anonymous struct. But what we want is the empty struct. And we are going to see why we actually want this in a minute, because there is definitely one big advantage of just using these empty structs. Now a different way, like I said before, is to just declare a named empty struct. And a named struct just in general is we declare a type right here, then we use something like some struct for instance, and then we use the struct keyword here to define the named struct. And in this case, this struct has the name some struct. Right here, this is the variable, but this right here is the type, or the struct type in this case. Now we will leave it empty because it is in the end a named empty struct. And this is the other way of kind of declaring an empty struct. And now we've declared this some struct, which is an empty struct, a named empty struct in this case. And then we can just declare another variable called some struct2, and we can use some struct right here. It's literally more or less the same thing. But let's just remove the second way because we are only going to focus on the first way right here, because this is the most common way to use an empty struct. Now the biggest advantage of using these empty structs is that they do not really consume any memory. And I'm going to prove it to you by just kind of printing the memory or the used memory of these three variables right here. So what we can do is just fmt.println, and then we use unsafe.Sizeof for instance, and then we're using some int. Right, we are doing the same thing for some string, and then we also use some struct, which is the empty struct. Now in general, unsafe.Sizeof just returns the size in bytes that a variable occupies in memory. So in the end, it just tells you how much memory space that variable takes up. And if we're going to run this file or this program right here, we are going to see 8, 16, and 0. And this is as expected because the empty struct just consumes no memory at all, while the other variables, which could be used as well, just occupy some memory beforehand. Why? And this is the biggest advantage of using an empty struct. So now you might wonder, why would you actually use this empty struct? Like I said before, these empty structs are really beneficial if you want something with zero memory allocation or something that is simply stateless. Now let's just take a quick look of how this empty struct actually works. Why does it not consume any memory at all? Now what we're going to say, just for testing purposes, is we are going to define another empty struct. Let's just maybe rename this some struct right here to empty struct, and then we are copying this empty struct and paste it right here. We are just redeclaring this as empty struct2, or defining a new variable in this case. And then we have two empty struct variables. And then we're going to use fmt.printf to basically just print the pointer or the memory address these four variables point to. And then hopefully it gets kind of clear how these empty structs really work under the hood. So what we can say to really display the pointer address of a specific variable is to just use %p in this case. And then we just, for formatting purposes, use \n right here. Now we are going to use empty struct, and then we're going to do the same thing with empty struct2, and then let's just also print some int here and some string. So again, %p really displays the pointer addresses in hexadecimal format. So it just prints the memory address where that variable is currently stored. Now for the sake of completion, let's just use a comparison here, or let's just print a comparison, and we are just going to use print line here instead, and just say the memory address of empty struct is equal to the address of empty struct2. Let's just execute this program here again, and what we'll see is actually 4 memory addresses. However, two are the same. And the ones that are the same are actually our two definitions of our two variables of the type empty struct. Now it is important to note here that this might be the case, so they may share the same address, but it is not guaranteed. Now, when looking at the source of malloc right here, it's also quite clear why these empty structs have 0 size and can share the same address. Malloc GC just shows that when the size of the object to allocate is 0, it just returns a pointer to 0 base. And 0 base is just a base address used for allocating 0 byte objects and doesn't really occupy any actual memory space. Okay, now that we know that how it actually works, let's just have a quick use case for these empty structs here. Now here we will focus on the most common use case, which is just using empty structs as channel signals. Now a few other use cases include implementing a set from scratch and, for instance, defining a method receiver in a really straightforward manner. In this case, the method receiver really means that we want to implement methods, but we do not really need to store any data in the implementation. And in this case, we can just use an empty struct. But let's just take a look at the channel signal first, and then we are also going to check out what it really means of implementing a set in Go. So let's just imagine that we have a normal Go routine right here, and we're going to start this Go routine immediately. In this Go routine, we are going to simulate some work, so let's just say fmt.println working, and then we are also going to sleep, for instance, for 3 seconds. Now what we could use for this Go routine is just a wait group that kind of waits until this Go routine has finished. But what we could also do is just a channel for signaling that this work has been done. So we can just declare a quit channel right here. We're going to use the make function, and then we can say shan and then struct. Now here we are going to create a channel for signaling completion, and because we are using an empty struct right here, there is no extra memory overhead, right? And then after the work has been done, we can just close this quit channel. So here we are sending the signal that the channel is closed and is done. And then we are going to block the main function until it receives this signal. So we can just try to receive a signal from the channel right here. So if we are going to run this code again, what we'll see is we will actually wait 3 seconds and then the program will kind of end because the quit channel has received a signal. And this is all done without additional memory overhead. Another example would be the context package and the context interface, which has a done method signature that just returns a channel used to signal the completion status of operations. And this return channel just uses an empty struct as its type. Now another example would be implementing a basic set. Now clearly we are not going to create a set here from scratch, but rather something really similar to create a memory efficient set. Now I think the set definition in general is quite clear. What the main purpose is that we are trying to track unique items without duplicates, and also we would like to have an efficient big O time complexity. Now examples would include tracking unique visitors, deduplicating data, or managing whitelist or even blacklist entries. So what we could say is we could define active users here, for instance, and what we would do is, or we would declare a map for this specific use case. As the key, we are using a string, and then for the value, we are just going to use an empty struct. And then what we could do is just active users, and then let's just say Alice, and then we can use struct right here. We can do the same thing for Bob. Okay, now using an empty struct as the value just saves memory because each empty struct takes 0 bytes, while each bool, for instance, takes 1 byte. So what we could also use, instead of using an empty struct as the value, we could also just use a boolean type. However, it would take up 1 byte per entry. Now in a set with thousands or millions of entries, these memory savings really become significant. I think it's quite clear that then we can basically check if the key Alice, for instance, exists in the map without really caring about the actual value. So what we could check right here is just basically exists, right? And then we could use the active users map. And right here as the key, we use Alice. And then if it does exist, we are just going to print Alice is active, right? Obviously the map lookup will return 2 values. The first value is just the actual value stored at that key, and the second value is a boolean indicating whether the key exists in the map. And then we can also just print the total active users right here, and then let's just iterate over all the active users and then just print them right here. Right, I think this is quite easy to understand and quite basic as well. And if we are going to run this code again, we're going to see that we have 2 active users. The first user is Alice and the second user is Bob in this case. And that's essentially everything you need to know about this magical empty struct type. Now I've got a few examples on this channel already, so feel free to check it out if you haven't already. If you'd like to learn a quick trick for making interface implementations more explicit in Go, feel free to check out this video right here. Anyway, thank you so much for watching, have a lovely day, and bye bye.